Hello, everyone, and welcome to Tomorrow Orbit 12.16. We're very glad to have you here today. My name is Jared. I'm going to be one of your hosts today because I also have the lovely Jade over here as well. And we're very excited to have our guest on for this week's Tomorrow Space episode, which is John Quinn, the co-founder and COO of Exos Aerospace, a very cool company that is doing reusability, but with a different type of vehicle than you would expect, or at least a different type of vehicle than what is the hot button for reusability at the moment. So, John, if we could just go ahead and get started, tell us a little bit of background about yourself. How did you sort of come into getting involved in aerospace?
Wow. You want the long version or the longer version? So let's see, I'll go way back. I started my career on Navy submarines, did that for a good number of years, did fast attacks and tridents, and I figured, that's the depth of the ocean. And then I got out of the military after about 14 and a half years and worked in power plants as a controls engineer. So I kind of got the land thing done. And this gentleman taught me how to trade stocks. And that allowed me to fire my boss. And when I fired my boss, I went back to develop some of these technologies that I had prototyped when I was on submarines. But guess what? The devices I was making back then, the electronics just wouldn't fit. And I ran across these guys, one guy from church, and he said, yeah, we can help you with programming those devices. And I was like, oh, well, that's awesome. And what struck me as I went to their shop is that they had $100,000 doorstops laying around everywhere. You ever seen a $100,000 doorstop?
No, what's a $100,000 doorstop look like?
It looks like a rocket engine to me.
Ooh, I'd like to put in an order.
They had made so many rocket engines that they're just laying around everywhere. And hey, they make great doorstops. So that impressed me, and I was like, why do you guys have all these cool doorstops? And they're like, well, we've made hundreds of different engines and dozens of flying vehicles. And our co-founder, or our founder back then, John Carmack, had to put the company into hibernation mode when he was part of Oculus, and they were bought out by Facebook for a couple $2 billion. I guess they didn't want him distracted from doing Oculus stuff. And so he just put it in hibernation mode. That was about the time I came along, and I said, you guys just can't stop. You have got to keep doing what you're doing. You've done with, on a commercial budget, what the world is doing and what governments do with hundreds of millions of dollars. So we can't stop. And I went back to that gentleman who taught me how to trade stocks, and I put together a business plan, and I said, you know what? This is an amazing opportunity. We need to get these guys back in space. And that's when we founded Exos Aerospace.
So with Exos Aerospace, what is your goal with that company?
Wow. We have many goals, but making space available is going to be first and foremost the primary. Because right now, if you want to put a payload into space, on June 29th, we can still make that happen. And in the commercial industry, it's very common for you to have a payload, and it's a year, 2 years, 3 years before you can get that in space. And right now, we can change that. If you call me in 2 weeks, we'll be about 30 days out from being able to put your payload in space, and we can still make it happen. So making space available is our mission. And there's a lot of reasons we're on that mission, obviously.
Wonderful. And that resonates pretty deeply, I think, with the entire Tomorrow family, because we're all about the democratization of space, as they say. And the fact that it's more accessible now than ever is just something so invigorating. So we're excited to see all the innovations that come out of that. So thank you for being a proponent of such things. So I kind of want to get into the origins of Exos, and more specifically kind of what preceded it. So born out of the ashes of Armadillo Aerospace, original contender for the Ansari X Prize. Why did Armadillo end? And also, Why do you think some of the employees wanted to continue their work / start Exos Aerospace? It means you must have had some pretty good prevailing ideas for them to want to stick around.
Absolutely. It was always about the passion for space for the entire team here. It was about that for John Carmack. And he would go where no one else wanted to go, or, he would have a vision for something and he would just go do it. And he would figure out a cost-effective way to do it. And, he was on the leading edge of just making things happen, right down from the lunar lander that they built for NASA and rebuilt, and, the early Pixie vehicle, the Morpheus vehicle. Those were all just challenges that John Carmack saw that the team just rallied behind him and made it happen.
So with all this going on with Exos, we have a question from our chat room that I want to go ahead and ask from Graham W. in our YouTube chat room, which is asking that, are you in competition with someone or are you in a niche market? And basically, what specifically at the moment is Exos Aerospace enabling?
All right, so excellent question. And I'll start with are we in a niche market? Up Aerospace would be a competitor. They're also a NASA-ready flight provider. NASA has a couple of programs for putting suborbital payloads into space. We can go out to Black Brant and, we can just straight up hire NASA to put that up. Or you can go to Up Aerospace, and they've taken a military missile, and I don't know their technology a lot, but they do have an 8-inch by 80-inch payload bay that they've opened up to carry suborbital payloads. So they would be kind of one of our competitors, except they're a different technology. They'll launch at 25 Gs. They're spin stabilized and super reliable, great company. They can get your payload up into space. But our vision is a little bit different, and we would probably align more with Blue Origin, where you have a very soft launch. We have about a 5G launch. We are not spin stabilized. We have a 20-inch diameter payload bay, and about 3 foot tall is kind of a standard configuration for us, and we can carry 50 kilograms to space. So we're kind of along the idea of, you'd never want to put mice in a mouse habitat on a 25G launch, but a 5G launch, yeah, you can still do biomedical experimentation on them and understand, how their DNA changes on an experiment that rides on a Sarge rocket. So Blue Origin also has that capability. They just launched 38 experiments into space yesterday. That's phenomenal. I think about 9 of them were part of the NASA IDIQ program that they're qualified for. And with 38 experiments going up, there was a lot of research done. So that's where our heart is. But their mission's different. They don't just want to do research. They want to put people up. And as soon as you mix people and payloads, you have impacted your micro-G environment. And they say right in their payload users guide that, they're not in it for the long haul to do biomedical research or any type of experimentation. They're in it to take people to space. So not totally a niche, but a great question. And that's where we're a little bit different, is we are focused on that research with this vehicle.
Ooh. Oh, a little teaser there. Okay. Well, thanks for diving into that and kind of explaining that. So we've kind of developed, why you're doing what you're doing and kind of the vision of Exos. So let's kind of dive into how you're going to do that. So you mentioned Sarge. Can you tell us a little bit about the design and capabilities of it as it stands?
All right. So Sarge is 20-inch diameter, 36 foot tall, approximately. Uses liquid oxygen and ethanol. It is a pressure-fed engine system. We use a helium bottle up in the very top of the vehicle. We pressurize that to about 5,200 pounds to maintain pressure on our fuel and LOX tank throughout the duration of the flight. And that also provides for pointing capability with ACS thrusters on the top and the bottom of the vehicle. We can carry, like I said, currently 50 kilograms to space on that vehicle. we have done a couple of flights of that vehicle, a 37-kilometer shot on our Pathfinder, a 20-kilometer shot on our follow-up, what we call Mission 1, and now Mission 3 coming up June 29th. Will be a 80-kilometer plus shot for qualifying for NASA IDIQ, so that NASA and the government can directly contract for us or with us to put payloads into space.
And Rebel from our RRC chat room is asking, why the name Sarge for your rocket?
So Sarge is actually all in caps: suborbital, autonomous, rocket, guidance, and entry. So we kind of use the G and the E. Plus, there was a push because I'm ex-Navy, so everything has to have acronyms. But I hated 3-letter acronyms, so this gave me a chance to have a 5-letter acronym.
Very nice. And one of the things that makes your suborbital rocket so interesting is that it is reusable. So it actually, it doesn't transmit back from the payload, or it's not one and done. It's actually reusable. And what makes a reusable sounding rocket much more advantageous over, say, flying on a sounding rocket like a Black Brant or a Terrier sounding rocket?
Yeah, let me ask you, Jared, how did you get to the studio today?
I came in my bright orange Jeep that I do all the time.
All right, wait a minute. You do all the time. Why didn't you throw your Jeep away when you got there?
Oh, because I don't want to do that. That would make it much more expensive, right?
Duh.
Exactly. So why do we throw our rockets away?
Golly.
Yep, there's no simpler way to answer it than that.
Such a profound insight.
Yes, exactly.
Gosh, we learned the hard truths here on Tomorrow. Wow.
So to kind of talk a little bit about some of the technology that you use, if you can talk about it, Astro YYZ from our chat room is asking, can you talk about your return to launch site parachute tech? How does it work? If you're able to say anything about it at all? Because I've seen footage of it, and it's really cool.
Yeah, so, it comes down to these guys back in 2009 were doing vertical takeoff, vertical landing. And they were flying vehicles, doing VTVL, great technology. And I'll even pick on our chief technology officer, Russ Blink. He actually sat on one of the vehicles that did vertical takeoff, vertical landing in a chair and flew on. So he's a bit crazy for doing that. But hey, it went up and went down. It's hanging from the ceiling here in our new facility that we just built, and it's dented up a little bit from a follow-on flight to that. So I'm glad he wasn't on at that time. But when you start looking at payload mass, for our size vehicle, and possibly for the next one, it takes about 3 times the amount of fuel in weight to do a vertical takeoff, vertical landing. So that being said, I can carry a whole lot more payload with having a drogue and parachute recovery. So drogue and canopy is a 2-stage system. We use the drogue to re-enter the Earth's atmosphere and to slow the vehicle down enough that we can deploy that currently 1,200 square foot main canopy to fly the vehicle back. And it's no different than the technology that the military uses when they throw things out of aircraft. So the canopy has about a 3-to-1 glide ratio. Great to see you've got that up there, flying back to the launch site. Can fly at about 30 miles an hour. So on that particular video, I think we had about a 40-mile-an-hour wind. So while it could still fly into the wind, it didn't make it back within 100 meters of our target point. So we did have to go out and drive a little bit to get it, but she set down relatively softly. And hey, this is still a learning curve for us. That vehicle set down about 900 meters from where we expected. Guess what? The elevation was higher than where we intended to land.
Ooh.
So it landed a little bit hard. So we're like, okay, what can we do? So we loaded terrain maps in the in the flight software program now. So no matter where it lands within our 7-kilometer safety circle, it knows exactly where the ground is, and it compensates for that, and it'll flare a little bit earlier to give us even a softer setback.
That is
But great question. I appreciate that.
Yeah, that's amazing. I mean, because it's such an elegant solution that on paper just looks so great, but then the fact that you were able to so successfully execute it is amazing. Because, I mean, I'm not going to lie, as soon as you said giant parachute or, canopy, all I could think of was those little army guys that used to have, like, the plastic that you buy in the quarter machines, you throw them, and they kind of, like, gracefully topple down. Obviously, your rocket does it a lot more beautifully than that, but thank you for bringing up that childhood memory. All right, so speaking of payloads, and so kind of bringing it back to making space accessible, we have a couple of really excellent questions in the chat that go along with this theme. And one of them is from Citizen 60087. What's the type range of costs for a student-based experiment to launch?
All right. So, okay, I'm going to jump away from the screen for just a minute.
Okay. That's
and
good. Going to grab
a couple more pieces. Because you've always got to have, like, payloads laying around your office,
Is that
right?
an Alexa?
So this is a 1U CubeSat,
Nice.
and about 115 millimeters square, has a cool little lid. And this is what our preferred payload bay is for, say, a student experiment. Now, these normally fly, if it was 1 kilogram, so 2.2 pounds, this would fly to space and back for about $6,000. We have had in the past funding from a program called, and we have a program for flying this, it's called Space EDU for education. And we actually had a dollar-for-dollar grant match on these. So this particular one has gone to space for as little as $1,500 with a $1,500 match. I've got another one flying on the current payload that's actually 1/6 of the size of this and 1/6 the weight, that's flying for $1,000. That's kind of our bottom line. We can put something in space, and this is where I challenge the Blue Origins of the world, because I was told when I started this company that we cannot afford to fly these payloads. And I'll be perfectly honest, at $1,000, we don't make anything on it. At $5,000 or $6,000, yeah, maybe we make a little bit, but we can't afford not to. So customer acquisition costs to get one of those payloads and to integrate it and everything else we have to do is very costly. However, it's not about making money on the payload. It's about creating tomorrow's engineers, scientists, technologists, and paving the way to go to space as a regular part of life. Obviously, the moon mission, the Mars mission, I'm not going to do that. The kids out there who are in high school today and in university today are the ones who are going to learn on things like this, or get a little bit bigger. And, we've got a Brick 66 here that will hold about 6 Petri dishes, and we can put biomedical experiments in space with this container that I believe will change the world and will change medicine.
Goodness. Well, thank you so much for delving into that. I don't know about Jared, but I got a little misty-eyed hearing all of that, because what we both do in our careers outside of tomorrow heavily have to do with promoting tomorrow's engineers and scientists and those who are really going to change the world, once we are old and can no longer hold iPads. So thank you. And I think that speaks a lot to Exos as a company, such a holistic company that, your bottom line isn't just your bottom line. It's perpetuating something much bigger than yourself. So thank you for kind of participating in that revolution. So
Yeah.
thanks.
Yeah, and to kind of continue a little bit of that with some of the interesting things that you guys do at Exos, we have a comment from Lars von Braun in our chat room here, which says, we want to make space accessible. Yeah, we've all heard that before. But then he also goes on to quote, if you have a payload that you want to go up on the 29th of June, we can still do that. Lars von Braun says he looks at the date. Okay, now you have my attention. So what's the advantage in being able to basically like come in and say like, hey, I'd like to launch a payload in 30 days. You guys got a space?
Yeah, so we've got a payload on board this time that's really neat. And I'm not even going to focus on the big university payloads, right? It's a thermodynamics experiment. And this is where, as adults, we learn, because it's made by Greater Nanticoke Trojans, it's a high school. And they basically said, hey, we're going to put a test tube with 4 temperature elements across it. We're going to put a heater at the end, and we're going to evaluate in space what thermal issues and what's different when you're operating in a vacuum. So, phenomenal experiment, but I gave them some requirements. I said, okay, it has to be able to withstand 11G. And they said, oh, okay. So guess what? They went out and they did the physics, and they figured in order for their experiment to survive 11G, they have to drop it out of the 2nd-story window at their school. And that's 11G. So they said, hey, we can do this. So they proved it. And then I gave them another requirement. I said, now I need you to make sure that that liquid, that water that's in there, isn't going to boil out and end up on my computer section or on somebody else's payload. So, Jared, Jade, how do you give me secondary containment of that water? Give me some ideas. I'll see if you get as creative as these high schoolers did.
I think secondary containment, I would definitely see about putting some sort of container around it. So something like that.
Too easy.
Okay.
Yeah.
Secondary containment, second container. I think you kind of gave us the answer there, Sarge.
Yeah.
Well, I did, but how much does that second container weigh?
Exactly.
Unless we put it in a bag.
Oh, Dutta said a balloon.
Balloon.
Ooh, a balloon.
But then balloon
What's a
adds
balloon doing?
buoyancy.
Hey, ooh, that's a good experiment right there, right? Well, here's what they came up with. They thought that the balloon could have air in it that would expand when you went into a vacuum and it might pop. So they said, no, we're not going to do that. They said the Ziploc baggie idea, but we'd never get all the air out of it. And then they said, what absorbs water and is really light?
I was going to, go ahead. Diaper?
Yes. Oh, you came up with it.
Yes. You know what? No. So,
You
okay.
just punked them. They called the Love's Diaper Company, and they said, hey, what's that powder that you use in diapers? And the Love's Company turned around and sent them a pound of it, and guess
that's
what?
Beautiful.
They used that to contain the liquid. It's super light. They use silicone around the test tube to encapsulate the powder, and if it broke, guess what? The diaper powder would recover all the water. And of course, they did the calculations to figure out how much of this powder they needed to absorb the 1.5 ounces of water in the tube. And voila, they have secondary containment at a weight savings from putting another container around it.
Yeah, definitely.
Fantastic.
Clever.
I'm impressed.
Clever. I'm impressed. Honestly, I'm not going to lie, because diaper was my second, but then honestly, the first thing I thought of was like maxi pads. You said what's light and can absorb liquids, but then the technology within it, okay, that's really cool. So I'm validated. Thank you. I know Jared and I both have a lot of questions we would like to ask, so would you like to take the lead?
Yeah, I was actually going to say that we actually have footage of a launch of Sarge. So, John, if you kind of want to take us through what we'll be looking at in this footage and kind of tell us what's going on at the launch that we're watching, we can go ahead and do that. So, I guess Dutta, whenever you're ready, roll that beautiful launch footage at any time you can. So let's see it. Okay, that sounds good. So actually, before our launch footage, why don't we jump into our chat room here to kind of ask some things about the Sarge rocket. Liam in our chat room is asking, how high does the rocket get, and how long are the payloads in a microgravity environment?
All right, so the vehicle is designed to go in excess of 100 kilometers. Obviously, with that recovery system, we've actually tested it at 95 kilometers on a prior vehicle. So we're pretty confident for 95 kilometers. We've made some improvements and enhancements. we do that between every flight. I think we had about 60 enhancements on the first flight, about 80 on the second flight. And that's kind of our timing right now between flights is driven by how much extra do we want to do. So this next shot will be targeting greater than 80 kilometers. If we touch out at 95, I'll be really happy so that we can evaluate the shoot. And then we'll push the performance a little bit more on the flight after that to break the Kármán line at 100 kilometers.
Nice. Very nice.
Amount of microgravity he asked about, anywhere from 1.5 minutes to about 2.5 minutes is what we're hanging our hat on from the modeling that we have at this point, depending whether we hit that 80 or that 95 to 100 kilometer mark.
All right. And John, we have got that launch queued up now, so let's go ahead and roll that beautiful launch footage. Tell us what's going on, John.
All right, so vehicle is fueled on the pad. We want to minimize the amount of time it's on the pad because we do have liquid oxygen that tends to boil off. We have liftoff here. Wow, look at that. It's a little bit crooked. It's about a 13-degree angle, actually. So we do have a gimbaled engine. And on that particular video, we came off the launch rail, and we actually ripped a launch lug off. Now, the picture right behind me here, if you were to look really close, you can actually see the launch lug right here in the video. Our GoPro that was on the launch stand caught that picture. And as the vehicle went up, that kind of tilted it on a little bit of an angle. The gimbal compensated. And we found, you know what? We need to do a little bit more tuning on our gimbal control to tighten that up so that we go straight sooner. Because anytime you're kind of fishing through the sky, it's not as efficient. And that's just something you learn as you establish the vehicle dynamics and understand your GNC control.
And what are some of the payloads that you've already flown on the Sarge rocket flights?
So we've done, there's about 10 different payloads on the first flight or 9 on the second flight. We'll actually be reflying every payload from the second flight since we didn't hit altitude. And I could run through the list, but they are posted online. And I'd say the most significant payload for this launch is a University of Central Florida payload. It is part of the NASA READY program. And it's actually a good thing that we had an opportunity to refly that payload because they had 2 of their 4 cameras failed on the launch. So they get a free redo of that because we didn't make altitude. And this time we believe we'll have all 4 cameras in their experiment working for this flight. So, and then the one that's near and dear to my heart, Center for Applied Space Technologies and Mayo Clinic flew a brick bioreactor in a canister. And they flew 2 of these comprising 6 experiments. If you go back and look through our Facebook, we did interviews with them and they can tell you exactly what those payloads were. But on this flight, on the second flight of the Sarge, they also had 2 of these bricks. Actually, the ones that they flew were a metal version of this because that flight was going to be exposed to the vacuum of space. So we couldn't have this Onyx version. We had to go to the heavier version for that. But they had cancer cells in a gel. And from the first flight to the second flight, they evolved to this gel format. And it's a space problem. When you go into space, you could have on a bioreactor in a canister or a bio wall reactor, the cells can actually slide down the wall and hit the surface and the cells will die. So if you can come up with a gel substrate that you put the cancer cells into, what we found on the last flight, and I won't speak for their final analysis and determination, but the preliminary report was that they had a higher survival rate of the cancer cells in that gel, allowing them to get more effective research out of the flight. And as many of you probably know, as soon as you leave the Earth's atmosphere, even our DNA shifts slightly. And understanding that and potential for advanced stem cell growth that Mayo Clinic and Dr. Zubair are working on with Center for Applied Space Technologies is something that I believe will be involved in the cure of cancer, of Parkinson's disease, and many of these other conditions, from heart disease to stroke. There's so much science out there that says that if you can activate stem cells, we have a leg up that we've never had before.
And also, we here at Tomorrow actually sort of want to give a thank you to you, because on the most recent flight of Sarge, we actually had a small container full of Tomorrow patches that I have right here. And these actually flew, the ones I'm holding actually flew on the rocket up with you. So unfortunately, I don't think we're going to publicly release these. We're kind of keeping them for ourselves here. But we have some rocket flown patches now for us. And that we definitely appreciate you allowing us to put our patches on your rocket.
Yeah, so Agronautics actually was working with y'all on that, and we're super excited to that, and that's right down to flying payload hops, and we got to join those guys out in Dallas for the launch of their Space Party beer that they made from the hops that flew on that flight.
Ooh.
So that was a pretty neat experiment to fly with the Tomorrow payload.
Mm-hmm.
Very cool. Well, that's exciting. And again, yeah, thanks for giving us the opportunity to turn these measly Earthbound patches into rocket patches. So thanks, Sarge.
Yeah, we got to get them on the next flight, because the next flight they'll be space patch.
Literally space patch. I know, I had to correct myself. I'm like, Jade, they're not space patches. Don't get ahead of yourself. But now I am.
Well, I mean, they flew on a rocket.
They were in a rocket.
That's still awesome.
It's amazing.
So, yeah.
I'm not trying to downplay that at all. But speaking of space. So now that we've kind of gotten a good idea of what Sarge is capable of and what you guys have going on now, we're really interested to see what the trajectory of all of this is. Like, what do you see as the future, not just for Sarge, but for Exos overall?
Okay. How far into the future do you want to go?
As far as you want to take us.
All right. Let's start short term. Obviously, taking payloads up is absolutely phenomenal. The biomedical research, again, being kind of our driving focus here. I have a vice president friend at Leidos who told me I don't need to do a biomed experiment. I need to do 50 of them. And I said, well, let's see, if we're flying our ambition for the September 26th and 28th flight is that we would fly the vehicle on September 26th. We would turn that vehicle within 24 hours with a crew of 7 people, and we would refly that vehicle on the 28th. So 2 days turnaround, basically. Within 48 hours, reuse our Sarge vehicle. And that capability would say, hey, if we wanted to fly once a week, or if we wanted to fly back-to-back missions, I could give them those 50 flights in 100 days with a 7-man crew. So there's kind of the driver, right? But then they said, okay, yeah, that'll give us the research, but then we're going to figure out from those flights what the incubation period is. So let's say that you wanted to activate stem cells. And today, through Center for Applied Space Technologies and Mayo Clinic, we know that if you put stem cells up on the International Space Station for a period of a couple of weeks, they will not only get activated, but they will have 100% or better growth rate. Now, what's so cool about stem cells is that they are what the body uses naturally to heal us. So let's say your liver is having a problem, you have inactive stem cells in your body, they go to healing your liver. So what if you could activate those stem cells? Now, not to get into the science too much because I'm not the biomed guy, but what I've been told is that just the fact that you can activate stem cells gives you a hand up and a leg up on treating cancer. Today, when we do chemotherapy and some of the radiation treatments for cancer, The cells that are not treated are those that are inactive. Well, what if through this research we found out that you could activate stem cells? You could actually then be able to treat the cancer. We wouldn't have someone that's in remission, but we would even have a potential to completely eliminate cancer in their body, or just be able to activate the stem cells so that our bodies can naturally heal themselves. That would be huge. Okay, carry that out. Well, maybe it takes a week in space, maybe it takes 2 weeks in space. So now I need to put stuff into lower orbit. So Exos has recently announced that we've signed a suborbital deal with the Basilicata region of Italy to manufacture our suborbital rockets in Italy. However, we are going out to Italy for about a month to continue working on that deal to expand to our Jaguar Leo launcher. This vehicle will be capable of carrying 150 kilograms to space. And I'm going to drag this out way forward 10 years from now when the regs actually catch up with the capability. What I would love to do is have this biomed company tell me, all right, we figured out the research. We need that payload to be in space for 12 days. And John Smith is at Medical City, Dallas, and we believe that we need to take his stem cells, activate them, and bring them back to him. I would like to see the day, and we have the technology to do it now, where we fly his stem cells to space, we throw them up there for 2 weeks, and then this container flies back and lands on the helo pad at Medical City, Dallas, and they go pull this out, they grab his stem cells, they re-inject them, and they let them go to healing in his body. So that's my vision for what I think we can do with biomedical research. And maybe it's for treatment of stroke, Parkinson's, heart disease, you name it. I think that what was naturally in our body to heal us will trump anything we've done as a man-made substance that may just hide the symptoms, but I don't believe it really does the healing sometimes that we would really desire.
Wow, so you guys are literally going to be developing a system that will allow pinpoint payload deliveries of whatever a customer needs.
Yeah, they've actually already proved it. We've got down mass capability. There are companies out there that have ejected small payloads from the International Space Station and brought them back pretty much to a pinpoint landing. And I believe that's just going to continue to give us capabilities that we don't even envision today. Yeah. But, getting through airspace in Dallas is a little bit of a dream because, now you have to coordinate all those things with aircraft that are flying. But someday this is going to be as routine as you buying a commercial airline seat. And I believe that a couple of years from now, flying this payload is going to be as easy as you going on our website, clicking through the little questions that we have out there, and you emailing us some paperwork and putting this payload on our vehicle. And, we're looking for the day where that's a 7-day review process and not a 30-day review process where it is now. And, being able to deorbit those things. And I'd like to send this back to your house instead of mailing it FedEx. Let me put it in space, deorbit it in your backyard.
Oh my gosh.
Yeah, I was gonna say you're gonna have to hit my backyard. I got trees in my front yard, so
it's like Amazon Prime on steroids. I don't know. I'm just a little dumbfounded with all these. Thank you for sharing that vision, though. That's a beautiful vision, and certainly the chat room is lit up with just how fascinating and just how, talk about having hope for the future, and as if we needed more of a reason to make space travel and aerospace relevant to the common everyday person. You really can't get more relevant or powerful than that you're literally curing things or on the path of curing things that, we've spent so long. And it turns out, perhaps space is the answer. Perhaps this is all kind of tying together in such a very hopeful way.
Yeah,
So.
I may end up going to the hospital for something and getting literally rocket therapy.
I
in order
mean,
to help with
hopefully,
that,
yeah,
so.
and then the insurance companies will catch up, and maybe it'll be, maybe you'll have some coverage there, with not too bad of a deductible. Anyways.
Yeah, you're just throwing some ideas out
Here's
there.
one more. Where my excitement comes from. There's he's 21 now. He was 18 when the experiment was done. 18-year-old young gentleman, paralyzed from the neck down, injected with 10 million active stem cells. And 6 months later, the stem cells have restored 2 zones of control in his spine,
Wow.
and they show him lifting weight.
Oh my gosh.
Now, if we can do that with active stem cells, I won't even touch on, I don't believe embryonic is the way. I believe that using a person's actual stem cells is the real way to do stem cell therapy. The science is far, far more aggressive with results from adult stem cells. And I just want to be a part of that. I think that we can change the world with stem cell therapy and, give the researchers the tools they need, and they'll make it happen.
Yeah, hopefully Exos can be a part of that, making that happen.
I'm sure it will be. My goodness.
Yeah. So a lot of people were asking about the launch cadence and, how quick can you turn around Sarge, which I believe you said somewhere 24 to 48 hours in there is what you're looking at doing.
So currently at Spaceport America, we have the capability, and Sarge was designed to turn in 4 hours. Now, we're still not far enough into repeated flights to say that I can safely turn the vehicle in 4 hours. But from the first 2 flights, we proved that we didn't have to do anything to refly the vehicle. It is between flight 1 and flight 2, short of improvements we wanted to make, it's rinse and repeat. And rinse and repeat goes into, you have to refuel the vehicle. It does take 8 hours to reload that canopy into the canopy bag. So, hey, we just throw our second one on there or our third one on there. And it takes a number of hours, about 4 hours, to fill our helium tank. So there's a 4-hour turnaround time item. But literally, we have the capability of doing it in 4 hours. To do it safe, we still go through and check every fitting on the vehicle, every wire, every screw, to make sure that nothing has come loose. And so far, first 2 flights, that proved that, hey, there's nothing we need to do. We want to see a full altitude flight to continue that assessment. And after that, we'll be ready to do the next couple of flights with a 48-hour turn. And really, why couldn't we fly 4 hours later? We want to make sure that we do it safe, and we will evolve to that. But I need a whole lot more people. I've only got a team of 15 right now total. With the expansion in Italy, we believe that'll hit 100 within a year. So, yeah, things are on the move up where I'll actually be training teams from Italy to support operations. And now I've actually got a second crew. So one crew could fly it on Thursday. Another crew could turn the vehicle and fly it on Friday. Right now, we're not looking for an afternoon launch simply because the winds at Spaceport America typically pick up in the afternoon to the point where we prefer not to fly. As we get better control of our tuning and we get these nice straight flights off of the launch pad and we start flying in those 20, 25 mile an hour winds, we can change that. But for today, we're shooting for the 48-hour. I don't know of anyone in the world who's turned a vehicle in 48 hours. So we're trying to make history.
Definitely.
Impressive.
Yeah.
Yeah, 48-hour turnaround.
That's still pretty impressive, yeah. So you mentioned that you're expanding to Italy and that you're expanding your team. So for those who are interested in joining this amazing Exos revolution, what skills and roles do you think are most needed for your company's success? What are you looking for in your team?
Wow, super excited engineers.
Yay.
So, we talk about STEM and science, technology, engineering, math. That's what makes a rocket go into space. that's where our focus is. If you go to our website, there's about a dozen positions posted right now. We will be hiring 12 leads probably within the next 90 days to kind of take the design of Jaguar that we have in CAD right now and start developing all the subsystems that will support the development of Jaguar. We intend to have a US-based lead team, and then all the support staff will be in Italy. We'll also be bringing an operations team in, primarily from Italy, to train them on ops, because as you guys well know, there's 118 companies I'm aware of at last article I've seen that are trying to develop LEO launchers right now. I'm aware of 2 of those companies who use the word reusable in that context. But how does a company go from nothing to operations? Anyone can make the vehicle. Anyone can fly something. But how many of them know how to operate a hydrogen vehicle, a peroxide vehicle, a RP1 vehicle, a LOX ethanol vehicle? So I believe that a key component that poses a huge risk for most of those 118 companies is they haven't been doing operations for 20 years. So while that talent is certainly out there and can be hired, I think that's the piece that's missing. The Sarge vehicle isn't about necessarily just payloads. It's about having an operational vehicle to train people on. And I can fly it. My ambition is not to make a bunch of money on our suborbital program. My ambition is to incent STEM education and to give me a platform that I can train people on. And I can have proficient operators to fly the vehicle, to do fueling operations, and to do that safely. Because guess what? We may be out. I mean, if 3 weeks go by and we haven't run our rocket engine, we're sitting back or we're working on a new project. You know, we are testing engines literally on a weekly basis. So that operational tempo you can't get any other way than having something that doesn't have to go to space to run it. You know, imagine running the space shuttle main engines every week. It just would never happen. So that's one of our strengths. So, you know, if you're interested in being part of that operations team, you have a specialty, I will tell you, everybody here will wear 2 hats, no matter what. That's a minimum requirement. So you might be a physicist who has a passion to be the guy out there actually watching what you've designed operate on the launch pad for a tie-down test or a hover test, or being the guy who's actually out there fueling the vehicle on launch.
So John, if people would like to get more info about you and Exos Aerospace, where should they go?
Well, it's a little bit on the website. Obviously, there are links from there out to Instagram, Facebook. We don't have a full-time social media team. We do have a couple people who do it for us. That's probably where most of the information you'll find is. So yeah, kind of check out our social media. Get out on our YouTube page, and I'll shout out everyone who's on here. If you could help us, we have this amazing technology on board Sarge. We have 2 360-degree fly cameras mounted on either side of the rocket. After a flight, we stitch those 2 videos together, so you can do a 3D virtual reality ride on the rocket. You will find that out there on YouTube. And we'll also stream our launches from YouTube Live if we have about 300 more people sign up to be on our YouTube subscribers list. Because today, we're only at 700, and they say we need to be at 1,000 people in order to live stream from YouTube in the future. So there's where you can help. Get out there. You can obviously get more information. We post cool stuff out to the YouTube Live. So please sign up for us and help us get to that 1,000 mark so we can stream YouTube Live on our next launch.
All right, everybody, you heard John. Go and subscribe right now so that you can have live footage of the launch, because if there's one thing that we really like here at Tomorrow, it's live footage of launches. That's
That's prime.
that's the good stuff.
Delicious.
So, exactly.
So you do need the words Exos and Aerospace YouTube, and that should take you right to our page.
It looks like somebody's posted the link in the chat room several times. So
Yeah, and we'll throw the link in our
Oh, they're
description
awesome.
as
yeah,
well.
you'll get
Thank
at
you.
least a good 1 to 150 subscriptions, I think, just from this episode. I mean, even if that's me creating 100 different accounts to subscribe, but just kidding, I won't do that.
You could do that.
But I'll definitely use my personal account.
Yes. So,
All right.
Thank you, Jade. And of course, John Quinn, the CEO and co-founder of Exos Aerospace, we want to thank you for coming on Tomorrow today. Thanks so much for stopping by. We hope to see amazing success for all the amazing ideas that you have in your future.
Fantastic. Thanks so much for having me on. Look forward to doing this again sometime.
Yay.
You know, and hey, you guys are always welcome to come out to a launch. And you know, we always have with seven people normally at the launch site. We always need extra support to run generators and keep internet up and stuff like that. So you know, you can't just come out and view a launch, but we can certainly put quite a few people to work on each launch if you have just a small skill set that we need.
I have a very small skill set. I would love to come help. Yes.
I can use a hammer. That's how you make streams work, right?
That too.
Exactly.
Yeah, that's
Make
how
sure
live
the
streaming
tubes are
works. You just
connected.
hammer the bit through the pipe.
Yeah, sounds good. And of course, not only do we want to thank John for coming on today, we want to thank all of our citizens of Tomorrow. Without your help, we would not be able to make this show possible. So if you'd like to help us out, if you got something out of this show today and you'd like to help us continue to do these shows, because we are a crowdfunded show. So there's no way to get around that. We depend on your support, and you have been great with your support. And if you get something out of this and you'd like to help support us financially, you can head on over to patreon.com/TMRO and subscribestar.com/TMRO and take a look at what you can get for the different tiers, depending upon what you feel. And then also, you can head over to community.tmro.tv if you'd like. If you can't support us financially, there's still a multitude of ways you can support us. Can you code? Can you get the word out? Can you post this on Facebook?
Can you create hilarious GIFs/GIFs of either of us doing
That's right.
something funny?
Can you make amazing hand puppets of the Tomorrow crew? Whatever you can to help support us. We accept just about anything and everything.
Literally.
So yeah, quite literally. So that's it for Orbit 12.16. Thanks so much, and we will see you next week. Bye-bye.